Hello and welcome. I am Dr. Pauline Fu. In this video, I will present the distribution of the sample proportion. At the end of this lecture, you would be able to describe the sampling distribution of a sample proportion, and you also be able to compute probabilities of a sample proportion. Let's start off by talking about the point estimate of a population proportion. Suppose you have a random sample of size n taken from a population in which each individual either does or does not have a certain characteristics. For example, you either are university graduate or you are not a university graduate. Another example would be you either live on campus or you do not live on campus. So just two outcomes. Okay? The sample proportion, we use p-hat. P-hat is given by x over n. X is the number of individuals having some special characteristics. For example, X represents number of students having part-time jobs. Okay, suppose I have 100 students and I did a survey. I found out that 65% of the students have part-time job. So 65 is X, 100 is N. Okay. The sample proportion p-hat, it is a statistic that estimates the population proportion, P. Remember, this P is a parameter. This p-hat is a statistic. Statistic relates to sample. Parameter relates to population. Now let's compute a sample proportion. In a university poll conducted on May of 2008, 1,745 registered voters nationwide were asked whether they approve of the way George W. Bush is handling the economy. 349 responded yes. Obtain a point estimate for the proportion of registered voters who approve of the way George Bush is handling the economy. So the question asks you obtain a point estimate. Obtain a point estimate for population proportion. So remember, the best point estimate for population proportion is a sample proportion, p-hat. We use p-hat to estimate P. P represents population proportion. P-hat, sample proportion. Okay, so we use p-hat to estimate population proportion P. But the question asks you to obtain a point estimate. Okay, so we use p-hat. P-hat equal to X over N. X, number of individuals having some characteristics. In this example, X 349, they said yes. Okay. And how many total people surveyed? 1,745, that is N. This is X, this is N. X over N, you get 0.2. Okay. So the final answer, the point estimate for the proportion of registered voters who approve the way W. Bush is handling the economy is 0.2. All right, next example. Using simulation to describe the distribution of sample proportion. According to a time poll conducted in June 2008, 42% of registered voters believe that gay and lesbian couples should be allowed to marry. Describe the sampling distribution of the sample proportion for sample size of N. Okay, this is the sample size. So let's analyze the result. It is used the technology, the simulation, okay, because this is a very large number. So this is the distribution of the sample proportion. Okay. This one, y-axis is the frequency count. X-axis represent the proportion. Okay, so in this situation, this is the sample size N. Okay. Actually, it is asked you 3 situations. First, when sample size equal to 10. Second, when sample size equal to 50. Third, when sample size equal to 100. So 3 situations. As you can see, as we increase the sample size, we would expect the distribution will be bell-shaped symmetry, or the distribution will be normal distribution. Okay. So this is the result when sample size equal to 10, and we get this distribution, not bell-shaped, a little bit skewed to the right. Okay. And when sample size equal to 50, approximately bell-shaped. And then when sample size equal to 100, it is closer to approximately bell-shaped. So key point from that example, the shape. As you increase sample size, the shape of sampling distribution of the sample proportion becomes approximately normal. So when you increase sample, this is sample size 10, sample size 50, and sample size 100. So when you increase sample size, the distribution of the sample proportion approximately normal. Second, the center, the mean of the sampling distribution of the sample proportion equal to population proportion P. So remember the question gave you the population proportion. Population proportion is 42%. So that is P. P equal to 42%. When sample size N equal to 10, the simulation result get the mean, that is the P hat, sample proportion 0.426. And when sample size equal to 50, this mean also P hat 0.426. When sample size equal to 100, you get P hat 0.42. Okay, this one equal to population proportion P. The third one, the spread. The standard deviation of sampling distribution of the sample proportion decreases as sample size N increases. If you look at the standard deviation, when sample size equal to 10, you get 0.16. the distribution like this, the spread. And when you have sample size equal to 50, the standard deviation 0.072, maybe this one, okay, standard deviation. And when you have sample size 100, the standard deviation 0.047, it is narrowed. So those are the 3 points we get from the simulation with regard to the shape, the center, and spread of the distribution. For a simple random sample of size n with population proportion p, the shape of the sampling distribution of p hat is approximately normal. Under condition sample size times p times 1 minus p greater or equal to 10. Remember what is p? P is population proportion. So this one has to be satisfied. The second point, the mean of the sampling distribution of the p hat, we use mu, then subscript p hat, that represent the mean of the sampling distribution of sample proportion. This one equal to population proportion p. The standard deviation of sampling distribution p hat, we use sigma, then subscript p hat, okay, which is this simple here. It is equal to square root p times 1 minus p over n. P, remember what is p? P is population proportion. Okay. The model in the previous slide requires that the sampled values are independent. When sampling from finite populations, this assumption is verified by checking that the sample size n is no more than 5% of the population size. Capital N represents population size. Okay, so sample size should be smaller or equal to 5% of population size. So when this condition satisfied, we know the sampled values are independent. Okay. Regardless whether n times p times 1 minus p greater or equal to 10 or not, the mean of the sampling distribution of p hat is p. The standard deviation is this formula. All right, so let's look at an example describing the sampling distribution of the sample proportion. According to Tom Powell, conducted in June 2008, 42% of the registered voters believed that gay and lesbian couples should be allowed to marry. Suppose that we obtain a simple random sample of 50 voters and determine which voters believe that gay and lesbian couples should be allowed to marry. Describe the sampling distribution of the sample proportion for registered voters who believe that gay and lesbian couples should be allowed to marry. The question asks you to describe sampling distribution. Okay. when you describe a sampling distribution, you need to describe two items. First, what is the mean of the sample distribution? Second, what is the standard deviation of the sample distribution? We know sample size 50 is given, okay, n equal to 50. And this 50 is smaller than 5% of all populations, all voters in the United States. Why you need to check this? Sample size less than 5% of the population size, you want to make sure that the independence. Here, you need to make sure sample values are independent. Okay. And then you check this requirement, n times p times 1 minus p. So 50 times 0.42 times 0.58 equal to 12.18 greater 10. Why do you need to check this? To make sure it is normal distributed. So that's why the sampling distribution of sample proportion is normal distributed with mean is equal to population mean 0.42. How do you know? Here, population mean 0.42. Okay, and standard deviation, you use the formula. Okay, this is p times 1 minus p divided by sample size n, and you get this one. Okay, so that is how you describe sampling distribution. Okay, you need to say what is the mean, what is standard deviation. Before that, you need to verify the requirements. Make sure sample size smaller than 5% of the population, and make sure NP times 1 minus p greater than 10. Another example. Compute probabilities of our sample proportion. According to the Centers for Disease Control and Prevention, 18.8% of school-aged children aged 10 to 11 years were overweight in 2004. 18.8% were overweight. In a random sample of 90 school-aged children aged 6 to 11 years, what is the probability that at least 19 are overweight? That is question 1. Question 2. Suppose a random sample of 90 school-aged children aged 6 to 11 years results in 24 overweight children. What might you conclude? So let's do question A first. You are given population proportion, P equal to 18.8. And the question asks you to calculate the probability of at least 19% were overweight. Before you do calculation, verify two conditions. 1, make sure sample size is less than 5% of population size. And number 2, calculate NP times 1 minus P. Make sure that number is greater than 10. In this example, N equal to 90. See here, this is N, sample size N, 90. P equal to 18.8 is the same as 0.188. So those two conditions are met. So we conclude the sample proportion p hat is approximately normal with the mean 0.188 and standard deviation, you use the p times 1 minus p divided by sample size n. Okay, so you calculated mean and standard deviation. And now the question asks you, what is the probability that at least 19% are overweight? Okay, so this question is the same as what is the probability, okay, X at least means greater than 19%. That is the question. What is the probability X greater than 19%? Okay. So we need to translate this 19% into a Z value. So this is the Z value for 19%. Remember the formula, it is equal to X minus mu divided by sigma. Z equal to X minus mu divided by sigma. X is 19% or 0.19, mu 0.188. See, this is mu. And sigma 0.0412. Where is my sigma? This is sigma. And you calculated the Z value. And once you calculated this Z value, the question asks you, what is the probability of Z greater than 0.0485? Okay. Remember, both Excel and the table is based on the area to the left, is based on smaller or equal to. So you need to translate this greater into smaller equal. How? How do you translate? You use complement event. You use 1 minus probability of Z. Okay. At least. That smaller equal to 0.0485. Okay, you translate this, change from greater to smaller equal. Use complement event, okay, 1 minus. So now let's figure out what is probability of Z smaller equal to 0.0489. You can use the table. Maybe the easiest way is to use Excel. I'm going to use Excel to do it. Use this cell so that it will not block your view of the question. So I'm going to use norm.dist. Okay, X 0.0485. Mean is 0. We use standard normal distribution. Mean is 0. Standard deviation is 1. Cumulative, yes. And we get this number. I'll just copy this formula. Here. So this result, this gives you 0.5199. Oops, 0.51. Actually, it is 0.5193 using Excel. Okay. 0.5193. Okay. Why it is difference between here? Because here you use 0.05. I use more accurate result, 0.0485. As you can see, when you round to 2 decimal places, you get different result as when I keep the 4 decimal places, but the result would be similar, okay? So 1 minus 0.5183. and you're going to get 0.4807. Okay, if you keep 2 decimal places, it is 0.48, the same as this one. Okay, 0.48. Okay. So we answered question 1. The probability that at least 19% are overweight is 0.48. So let's answer question B. Suppose a random sample of 90 school-aged children aged 6 to 11 years results in 24 overweight children. What might you conclude? So first, we calculate sample proportion p-hat. So x equal to 24, n equal to 90, and we get this number. And then translate this number into z value. We get z value 1.91. Okay. And then we calculate the probability of z greater than 1.91. So again, to calculate this, it is actually equal to 1 minus the probability of z smaller equal to 1.91. And then what is the probability of z smaller equal to 1.91? You can use table or use Excel. So I'm going to increase font size. So equal norm dot dist x is 1.91, mean 0, standard deviation 1, cumulative yes, and I get 0.9719, same number as here. Okay. So this Excel would give you 0.9719. And then you have to use 1 minus this number. Finally, you get this result. So how do you interpret this result? This number similar to 0.03. 0.03 means we would see about 3 samples in 100, resulting in a sample proportion of 0.2667 or more. Okay, this is unusual sample if the true population proportion is 0.188. So that is our conclusion. Okay. All right. So in summary, what we did in this video, we describe the distribution of sample proportion. Okay, so when you describe the distribution of sample proportion, usually you do 3 things. 1, verify the conditions are matched. There are 2 conditions. 1, sample size smaller than 5% of population size. Second condition, n times p times 1 minus p greater or equal to 10. So this is 1. And second, you calculate the mean of the sampling proportion. Okay, and the third one, you calculate the standard deviation. Once you have the mean, you have standard deviation, you can calculate the probability of sample proportion. Okay, that's all for this lecture. Thank you so much for your time. I look forward to see you next time.